Thanks. So this is actually the third time I've been able to give this a talk at OWASP this year. I gave it in AppSec DC, AppSec EU, and now here. And it's evolved a little bit, but not tremendously much. So I'm going to talk about, first off, what DOM XSS is. Probably a lot of you are already familiar with that. And then talk about some terminology confusion there is around DOM XSS. And I'm actually going to propose some new terminology, and then talk about some research that I've done and research that still needs to be done to try to really enable both application security professionals to find DOM XSS and also to help developers avoid introducing it in the first place. And I'm also going to talk about a new OWASP project that I plan to start up in the fall with some help from some other people I've talked to. And also, if you guys, of course, are interested in participating or contributing, we'd love to do that. So if you're interested, let me know after. So background on myself, she basically did that. So this is just for the slide deck when it gets posted, so I'm not going to go through it. So what is cross-site scripting? You all know what that is, but just a refresher real quick. All it is you take some input from the user somehow. It's usually where they enter it in, but it could have been stored somewhere in a database and coming out. That data gets included in the response back to the browser. The browser gets confused about that data and thinks it's code. And of course, when it executes, something bad happens. In this simple example, a little dialog pops up. So I'm assuming you guys are all familiar with that. I'm not going to spend any more time on that. So now DOM-based XSS is a little different, though. It's not that the entire page response came back with this vuln in it. Instead, with DOM-based XSS, we've loaded our page already. And then we're using AJAX to get data back and forth from the server, or our AJAX, our JavaScript is actually reading data from the browser environment, taking that data, updating the DOM with it, and then causing cross-site scripting. So it's not the whole page where data got included in it. It's actually the page is dynamically updating itself and getting unsafe data, and that's what DOM-based XSS is. Now, so you've all seen this categorization of stored and reflected, which we're familiar with, and then DOM-based XSS, they call it this third category. But the problem with this terminology or this organizational model is those are not distinct from each other. You can have stored DOM-based XSS, and you can have reflected DOM-based XSS. So that's not the right way to organize the problem, for one thing. There's another problem as well. I've had some arguments with Amit Klein, who's the one who originally discovered the problem back in 2005, and some other people that I respect a lot in this space, about what is DOM-based XSS really cover. And Amit's definition is, well, the data has to come from the user or come from the browser and never leave the browser. In other words, it never goes to the server, and then it doesn't and it come back from the server. So it has to stay within the browser. The problem is you can also have cross-site scripting where the data comes from the user, goes to the server, comes back to the browser, and then has a problem. And according to Amit, that's not DOM-based XSS because it left the browser. I'm like, OK. It seems like splitting hairs, but they didn't want to change the definition to say, well, we don't care where the data comes from. If it's caused by a JavaScript update, that's DOM-based XSS. They didn't want to include that. I'm like, all right, well, I'll just invent my new terms, and I'll show you what those are. So here's a simple example of the bunch of different ways you can have XSS. So here's user input into a form. Now, they could have JavaScript that immediately updates the DOM to say, like, hi, Bob, or whatever. And if they do that unsafely, that can introduce an XSS vulnerability. So that is definitely a DOM-based XSS. That data never left the browser, and yet it's causing a problem. Now, you could persist that data in like an HTML5 database or some other place, or put it in a cookie and get it back out of the cookie or whatever. So that's, again, DOM-based XSS. It never left the browser, but that's persistent or stored cross-site scripting, depending on which term you like for that. Now, you can do the same thing by sending it to the server and it coming back immediately. Now, that's technically not DOM-based XSS because it left the browser. It seems like the same problem to me, but that's per their definition, not the same. And of course, it could be permanent as well. You can store it in a database and it comes back later, right? So to me, all of those are DOM-based XSS, but Amit says, nope, I don't want to, those two that go to the server don't count. So what am I going to do? Well, I'll invent a new term. So this is what I'm proposing, that we think about cross-site scripting as where's the source of the problem. In other words, did server code create that page with the embedded data in it, and that's where the cross-site scripting originated from? Or did client code take that data and put it into the DOM and cause the cross-site scripting thing? That's really the fundamental distinction in my view. So that's what I'm proposing is these two new terms, server XSS and client XSS. So server XSS is kind of what we're used to, where a whole page gets served to the browser, and there's some data embedded in it unsafely, and we have an XSS problem. Now, of course, you can have stored and reflected server XSS. That's what we're used to. And you can also have stored and reflected client XSS. Now, client XSS, of course, includes DOM-based XSS, because that's basically a subcategory. But it also deals with the situation where the data goes to the server and comes back. So anyway, that's something I'm proposing. When I get some time, I'm actually going to start writing some articles at OWASP about this, and we'll see if the terminology takes off or if everyone decides to ignore me. We'll see how that goes. So this ends up with a new chart, and I think this new chart is makes a lot more sense. It's more organized. There's no overlapping in this way. So with client-server XSS, of course, you have stored and reflected. So those are the terms I'm proposing in the intersections of those two things. And so that's some of the terminology that my company is starting to use to try to clarify the problem. And I think as a developer and a consultant, when I see that term, that tells me is this persistent or not? And also, where's the problem? Is it on my server code? I mean, ultimately, all the code comes from the server, of course. But where is that code running? Is it server-side code that's introducing the problem, or is it JavaScript that's been loaded in the browser that's running that's causing the problem? That helps you zero in on where to fix the problem better. So now, DOM-based XSS, like, why should I care about this problem? I discovered it in 2005, said, oh, this is kind of interesting. It's probably going to be more interesting in the future, but I can't predict when. Well, back in 2005, we had very little code in the browser. Most websites didn't have a gigantic amount of JavaScript then. But obviously, as we know now with Web 2.0 and so on and so forth, the amount of JavaScript we have in our applications is enormous. I mean, we're talking about upwards of 25–30% of our code is JavaScript now in a lot of websites versus, back then it was a very small number. So because of this massive amount of client-side code that we have now typically, obviously the possibility or likelihood of having DOM-based XSS has grown by several orders of magnitude because of the volume, right? So this data comes from IBM, by the way. So IBM has also been doing some analysis on this, where they've actually been studying large public websites. And so they went out and looked at the Fortune 500 plus some other websites that they decided to test. And I'm not sure why they selected what they did. But what they found was, with their technology, they were able to, through automation, find that 40% of those websites had DOM-based XSS. And I'm not surprised at all. In fact, I wouldn't be surprised if that number is much, much higher. Clearly, just through automation, there's things that obviously their tool's probably going to miss. And what they also found was also interesting was 90% of the cause of the problem was third-party JavaScript libraries that the developers were using. Now, what I don't know is their definition of what does caused by the other library mean. Does that mean they used a third-party library and the combination was the problem? Or did the library directly introduce the flaw? I'm not sure of the details there. But there's certainly definitely a big part to play in DOM-based XSS or client XSS from the libraries. And I'm going to talk about a couple of common libraries like jQuery later on to illustrate some of this. So what's the risk of client XSS? Well, it's really the exact same as normal XSS. In other words, the damage, the impact of having this vulnerability is identical. The real difference is how likely are you to find and fix these flaws in your application versus having these flaws unknown in your app. And I think the likelihood of you having unknown DOM-based XSS flaws or client XSS flaws in your app is much higher because very few people know how to find them. So we have worked with a lot of large clients, and sometimes we get the opportunity to look through their portfolio of reported vulnerabilities that have been found and been fixed and so on and so forth. And we're not seeing hardly any significant reporting of client-side XSS in these large databases for our customers. And yet I know they're there. I just don't, the tools don't find them. A lot of the consultants don't look for them, or the internal team, whoever's doing the audits, they're not looking for this problem So I think this is just this gigantic latent problem that they're not looking for, and yet I know they're there. So the risk is basically the same, and yet we're not solving this problem. That's a big issue, of course. So let's just look at the classic example. This comes right out of Amit's paper. So he's like, imagine this. You've got a website that takes a URL, and it parses for a particular parameter, the name parameter, and simply updates the web page with a method called document.write, which is in JavaScript is one of the methods that's vulnerable to XSS if you pass unsafe data to it. Now, in this example, they're imagining the user is going to say, like, Joe, right? So they go in and look at it, and they pull out the name and put it out there. Now, what's interesting is this can be done in a couple ways. Now, that name Joe equals Joe parameter could go to the server, right? So you could put your attack in the actual name parameter. It could go to the server. The server code could then validate that name and go, oh, there's some funky characters in here, and I'm not going to send that back to the browser. So you could fix part of this problem with server-side code. But what Amit says, look, I can do something cool. I can create that would be the classic normal attack, right? So you could do that. Now, what you could also do is instead create an anchor in your URL and put the name parameter also in the anchor, and the anchor does not leave the browser. So the actual URL that gets to the server in this case is, blah, blah, blah.htm, and then everything from the # over to the question mark doesn't go to the server, and then you have question mark name equals Joe. So the server would see name equals Joe. That looks like a perfectly valid name, no problem. So it would respond with whatever it does, and then this code would pick this, and it's doing a naive parse of that URL. It's like, let me find the first value of name in the URL, get the value, and update the page with it. Well, of course, it's going to grab not Joe, script, whatever, pop that into the DOM, and it executes, and game over. So no server-side code can fix this problem. You have to have client-side code to fix this problem. And how would you do it? Well, luckily, you can solve the problem in the same way as normal XSS, validation or encoding. So one thing that's sort of not unique about DOM-based XSS is the same defense techniques apply. You just got to put that code in your client-side code, not just your server-side code, right? There's one extra thing you can do to avoid this problem that I'll talk about later. So there's a slight advantage in this side over the server-side thing. So anyway, that's sort of like the classic attack. Now, why is it hard to find this client-side XSS? Well, how many of you guys are middling good at understanding JavaScript? Yeah, wow, that's pretty good. So when you got thousands and thousands of lines of JavaScript, you think you can follow the bouncing ball through all that stuff and find where the dangerous data starts from, and then how it propagates through all that JavaScript, and then finally gets to an unsafe method? How many of you guys think you can do that? I think I saw 0 hands, right? And it's really hard. I mean, JavaScript, well, not only is it hard even if you had all the code laid out in front of you, but the JavaScript gets loaded dynamically, it changes dynamically, they load new things, they replace things, they redefine methods, and it's just crazy. So it's really, really hard, right? Some of the other things that we need to just even do that is we need to know where the dangerous sources of data. We need to understand propagators, which I'm not going to cover in this talk. We also need to know which methods are unsafe. So if I go back to the question like, well, is it easy to follow all this through? No, that's not it. Let me ask a simpler question. How many of you guys know the list of methods in JavaScript that are not safe? Maybe a couple of you, because there's actually some wiki articles that say this is the list of unsafe methods, right? Well, we need to know that. But the problem is we're not all writing raw JavaScript on the bare language, right? We always use JavaScript usually on top of these JavaScript libraries like jQuery and name your favorite library, right? So you need that same information at the library level that you're using, because you don't know what's going on under the hood of that library. Now you could, because all those libraries are JavaScript, you can of course get the source code for all those libraries and go into the bowels of their implementation, but of course who has the time to do that, right? So let's talk about dangerous sources of input. This is in the browser, right? So the page itself could create or update the DOM. That's what. So one dangerous source is you send a page from the server to the client, and there's embedded user data in there. That's the typical unsafe source that we're used to, right? But what I could do is an AJAX call to do the same thing. I make an AJAX call, I get some data from the server, and then if I update the document with the unsafe method, in this case enter HTML, I have a cross-site scripting flaw, right? So this is the source of the data is the server, it's the same, but it's the way the DOM gets updated is different. Whole page versus a dynamic update. Now, I can also, in my JavaScript, just decide to grab data from the DOM through the document object, window objects, things like that. And those are other sources of dangerous input. So what happens is the user interacts with the website, the DOM updates itself, and then now it's got this data lying around that you could choose to grab and use if you want to, and a lot of developers do that. I could also have the user directly filling out a form, or on an on-click or an on-blur or anything, and that can be a source of data as well. And then finally, the actual JavaScript or style sheets that come from the server are possibly a location of dangerous content, but in reality, usually not, because usually they're static, and so they're trusted because they're static content from the server. But it's possible that someone could be dynamically building a style on the server or dynamically building a JavaScript something and then sending that to the server. Oh, that's not as common as these other locations. Now, to provide some details on what all these look like in the actual browser, what kind of encodings they use, what kind of format the data looks like, Stefano DiPaolo from Minded Security started this wiki project at Google called DOM XSS Wiki. And he started, but hasn't finished, because that's one of the always the struggles, it's a lot of work, is to start documenting his understanding of all the different ways these resources work across all the browsers, because they're not consistent with each other as well. And so this just gives you some basic information if you're interested on how that works. I used to have a lot more details on this slide, but I took them out because it was too much of an eye chart. But anyway, if you want to know, if I call document dot whatever your method, what data will you actually get? What part of the URL do you get? The whole thing? You get the domain, you get the parameters, what the anchor, what do you get, and what's the format of that data? So that's what this is trying to document. Now, what are some dangerous JavaScript things? That's the thing I mentioned before. Here's some. This is not all of them, but it's most of them. A lot of these are documented directly in the DOM XSS prevention cheat sheet. If you're not familiar with these cheat sheets at OWASP, by the way, just a little sidebar, we started off with this very first article called the Cross-Site Scripting Prevention Cheat Sheet. And the idea of that cheat sheet was to give the developers as short as document as we could write that explains how to avoid this problem in their code. Prior to that, a lot of people used to refer to RSnake's XSS attack cheat sheet, if any of you guys are familiar with that. And that's like 150 pages of really interesting and cool evasion techniques to cause XSS. Well, we used to point developers at that mess and go, yeah, all that danger, do something to make sure all that danger doesn't happen, which their eyes glaze over. It's impossible. It's too much. So instead, we have a 3 or 4 page article on how to avoid the problem that all those things try to attack. Well, that was pretty popular, so then we wrote a SQL injection prevention cheat sheet, and now there's like 40 of them, right? A bunch of them are drafts still, but I think there's at least 20 of them or so that are not drafts. So if you're not familiar with the prevention cheat sheet series at OWASP, I would certainly encourage you to become familiar with that. Tell your developers about that, because it's really great, really small nuggets on very narrow topics on how to deal with certain things, like how to manage sessions right, how to use SSL correctly, how to store passwords correctly, how to deal with XSS, etc. So anyway, that's the DOM XSS cheat sheet. It has a list of dangerous JavaScript methods in it, which of course is useful. So now here's some safe syncs. So one of the things that would be better if we had better details is like, well, here's the unsafe syncs, but oh, by the way, here's similar methods that are safe. So if you want to update the DOM, but you're not intending to introduce new HTML and new JavaScript, in other words, you want to say hello world as just text, how do you do that? Well, these are safe methods like element.enterText or formField.value. So when I say danger, which you probably can't see that little red dot, the danger means you've got all kinds of evil content in there, but that method is resistant to attack even if you're passing evil content in. So the developers need to know the unsafe methods and the safe ones Because the safe ones, they can just pass whatever, and it's safe. And the unsafe ones, they got to know it's unsafe, so they know they validate or encode before they pass it in, or they choose not to use the unsafe one, they use the safe one instead. Right? We need that. Now, of course, it's not just about JavaScript. Right? There's dozens of these huge libraries that people use. jQuery is one of the most popular ones, so I started some analysis on this for a client, and this is the results I came up with for this particular client. Unfortunately, the client said, we use this part of jQuery, so we're paying you to look at that part of jQuery. So unfortunately, this is not a complete set of analysis. But what we did determine was about these, I don't know, dozen-odd methods are unsafe with respect to cross-site scripting. And there's also some methods that are also unsafe because you can do redirects too at the bottom. But I'm focusing on the cross-site scripting part. So here we have like 11 methods in that middle box that are unsafe in jQuery. Now, it doesn't mean jQuery is broken. Just like JavaScript's not broken, right? You can obviously add HTML and JavaScript dynamically with JavaScript, and that's on purpose. But you need to know the unsafe methods versus the safe ones, right? So I'm giving you 11 that are unsafe. We looked at 170 methods. What I haven't formally published yet, and I will, is what are the other 159 methods that we determined were safe. Now, there's another 140 methods that we have not looked at. Luckily, I had the opportunity to work with a couple grad students at Hopkins that are looking for a master's project. And I said, hey, I got this project in my pocket that I need someone to do. Will you want to finish the work that we've been doing and publish this not only for your project, but at OWASP as an open source project? And they're like, yes. So they just started, and they have to be done by the end of December to graduate on time. So I predict they will be done by the end of December. Otherwise, they have to pay tuition in the spring, even though they're not taking any classes. So hopefully they'll finish that project. Now, what did we do? We actually built a test harness where we can actually load the library and build test cases and actually test, rather than just human analysis, actually test and verify that we were able to execute JavaScript by passing data into one of those jQuery methods. And so that's how we identified those 11. We actually built about 20-odd actual tests, and then we analyzed all those other 150, and we felt pretty confident that they weren't vulnerable, but we didn't build formal tests for those other 150. So we could be wrong about the other 150. There might be a few more that are vulnerable. We don't think so. But so what these two guys, Ryan and Kavya, are going to do is they're taking the test harness that I've already handed to them and the tests we've already built, and they're going to try to write the other 290 test cases. Now, that might sound like a ridiculous amount of work, and I'm sure it is a lot of work, but most of the test cases are very similar because they're based on the data type. So the same kind of parameter is used in a lot of methods, but the attack on that type of parameter is very similar. So we've already got a lot of tests for all the different data types. We think they can just sort of crank those same kind of tests out for all the other methods. So again, it's not just 310 tests because a lot of these methods take multiple parameters. So you got to test each parameter one at a time. So it may be 1,000 tests that they got to write. Hopefully they can get through it. But if they don't get all the way, they're going to, as far as they can get, they're going to get those out and get them published. Now my goal is to get this out at OWASP and then say, hey guys, this is what we found. I want to call jQuery and go, oh, by the way, this is what we figured out. Is anything in there smell funny to you? If they see methods on the list that are dangerous that they think shouldn't be, then hopefully they'll fix that. And as an example, one of the primary methods that's dangerous in jQuery is the actual jQuery method, the dollar thing, right? So the dollar method is unfortunately is overloaded. You use it as a selector to get a handle to a JavaScript object, and you also can create HTML and JavaScript with it, the same method. Well, this use as a selector is the most common use case. Most people say, give me the reference to this named object, and then go do something with it. Well, unfortunately, if that named object, the name of that object was the name of a value of a parameter from the user, and they put a bunch of JavaScript in it, and bang, bad things happen. So we've been discussing this with jQuery recently, and they actually agreed and have actually implemented a change to jQuery, the dollar method, which is the same method. So in 1.8 version of jQuery, if the first character of that input is not a less than, then any JavaScript embedded anywhere in it, anywhere else, is going to be treated as text. So if you pass in a selector, as long as you verify that the first character is not a less than, then you should be safe from injection. So that's an improvement. But it's still kind of weird to have this sort of multimodal method that's kind of dangerous. So I think they've also said in version 1.9, I believe, they're actually going to come out with a couple other new methods that say, look, you should really be using this method under this use case, and it's safe, and then only be using the dollar thing under this condition, so you get better division there. So not only are we providing valuable information for developers to potentially know which methods to avoid and not to avoid, but we're actually causing improvements in the libraries, so they fix some flaws in them, so nobody has to worry about those issues anymore. So anyway, this is one library. So right, how about all the other ones? And this is just a few. I mean, there's dozens and dozens of them. And in fact, even when we go to jQuery, it's not just jQuery. There's jQuery UI and jQuery mobile and blah, 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 right? So there's half a dozen of these libraries frequently for each major provider. And we need this information for all of them. So what I'm hoping to do is to do a really good job on one, open source everything, including the test harness. And I'm hoping I can either shame or encourage the vendors to do the same kind of research on their own libraries and publish that so we have a chance of doing this right. Now, I know this is massively ambitious, but hey, that's how things get done, or at least what I try to do at OWASP, right? So here's an example for you guys. So this is another library. And so this is some code I looked at last month. So here's the question. So first off, is there a vulnerability in this code? And the answer is yes, but it's not obvious. So let's go through this real quick. So imagine you're the developer and you wrote this code, or you're an auditor looking at this code, you're trying to find the vulnerability. Well, first thing you do is, well, where's my dangerous input? So here's these 3 request methods where we're getting data from the request. So we know that's obviously potentially dangerous. So that's the source that we're worried about. Now we've got to go, where does that data go, and is it safe? OK, well, if you look at this code, you see that there's this method called getWhateverText, and they all return this Sentia GXT object called blah, 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 text. So it's a text object. And then there's this method called setText, and you pass data to it. So is that safe? Does it look like it should be safe? Would you look at that and go, oh, that's obviously broken? No, you go, data called text, setting text. I expect it to be text and stay text. Rational, reasonable analysis. And we would be wrong. It's not safe. Why? I don't know. But I looked in the code, and I found under the hood, they call set in an HTML on that data, and that was the problem. Now, they should have called set inner text, and it would have been safe, right? So I contacted the lead of this project, and I said, this method's broken, and here's why. And he's like, yep, you're absolutely right. It's broken, and we're going to fix it. So great. One minor victory. How big is that API? I have no idea. It's probably hundreds of methods with dozens of parameters, and God knows so forth. Somebody needs to go through that library too and do all this analysis and figure out which ones are vulnerable. And then the ones that are broken vulnerable will fix, and the ones that are known to be vulnerable because they're supposed to will know. Here's the unsafe list, and here's the safe list, right? But no, I mean, this is what developers are dealing with. They have no chance of getting it right when libraries do stuff like this. And even when they don't do broken stuff, there's a set of dangerous methods, and they don't know what they are. They don't know which ones are dangerous, which ones aren't, right? So that's what we got to fix, right? So that method should be, and it will be fixed. I only reported it a couple weeks ago, so I have no idea. He didn't give me a time. I didn't press him. We'll see what happens, right? So how do I avoid cross-site scripting? Well, you can use the same defense techniques for server XSS on the client side as well. You can do, if you obviously don't include dangerous content in your method call at all, you're safe. You can do that on both sides. If you need to include the dangerous method data in your call, then you either validate it, which is hard, or you encode it, which is a lot easier. Now, the thing I really like, though, that you can't do on server side, but you can on client side, is the client side, if you know a method's safe, you can just call it and you're done. You don't need validation, you don't need encoding. But the only way for you to do that thing is to know that method is safe. And right now we don't know for most of the libraries because nobody's done the analysis. So this is the data from the XSS cheat sheet. Talks about the different encoding contexts. I'm not going to go through this, but there's 5 different scenarios that you can have XSS in a regular page where you load the entire page. HTML, JavaScript, style sheets, URLs, etc., etc. And the same exact encoders, of course, are in the browser itself, and you can do the same thing. You can validate or encode. And there's a JavaScript library as part of the ASAPI project. That's the ASAPI JavaScript library that has the same exact encoders. So this cheat sheet refers to the ASAPI library for Java and .NET and so forth. This one is the same chart except for the ASAPI for JavaScript. So you can encode in your browser. You take the data, you encode it, and you use it, and you know it's safe. But you got to know the right context, and that's the tricky part. So let's go through these examples of actually building defenses. So I want to add input validation. Great. So here's an example, right? Now, is that hard? That particular example, 5 digits, isn't that hard. But imagine you want to validate an arbitrary string, like a blog post comment or whatever. So validation is definitely possible. It's strongly recommended, but it's not simple. You don't just wrap the data in a method call, declare victory, and move on, because you got to figure out what the validator is. You got to write it. You got to regression test it. It's a pain in the butt. So not that it's bad. It's just complicated, right? So avoiding the JavaScript interpreter is my best recommendation. Like, in other words, use the safe methods. But we don't know which methods are safe. So that's it's a good advice, but without the data to say which is safe versus unsafe, it's very, very difficult to follow that advice. So that's why I'm trying to get that data out there. So here's another example of a client-side XSS, right? So you guys see where the problem is in this code? I'm building some HTML, right? Even the variable says HTML. And I've got all these constants in blue. And I've got this one thing in black, which is something from the URL. So that's clearly user data. And I'm just building a big string and concatenating some user data into the middle of it. And then I'm saying, build me some HTML out of this. Well, clearly, that's a problem, right? So that's the dangerous content. Here's my attack vector. This is when I do that append using the dollar in jQuery. I end up with this actual HTML and JavaScript in the browser. And what I've done in this case is I've added an onBlur event to this form. And so when you click in that field, bang, XSS happens and that thing, right? So how do I fix this problem? Again, normally you do validation or encoding. That's what we're trained to do. But in this case, we can avoid the interpreter. Instead, we can say, well, let me show you how validation works. Here's an example of a regex, which is God knows what all that does. But the only thing actually dangerous in this whole thing was the double quotes. If I can't put a double quote into my attack, I can't break out of the form field to inject my own JavaScript. So in fact, this regex was already in the code. It was already there to try to validate that URL. But the one thing it didn't look for is to make sure there were no quotes in the URL. So that he just added this extra check of I'm looking for quotes, and if there's a quote in it, he rejected it. So did that fix the problem? Well, unfortunately, it didn't. Because the way this code worked is you fill out this form, and then it sends the data from the client to the server, and it remembers that value, and then it sends the data from the server back to the client later, and then it builds that form the way I was showing you before. So we've added input validation. The problem is I can bypass all this JavaScript entirely and just build a URL and fire it at the server with whatever I want in it. The server remembers that, comes back, and executes this code, and bang, you have a problem. So yes, you want to do input validation, but if you can bypass the input validation and send the data directly to the server, or jam it in the HTML local storage or whatever, you may not be able to evade the input validation, and you have a problem. So here's the better solution to this, is to not build that HTML with any user data in it at all. So build the form with a static set of content, and then once it's built, update the value later. And this .val method is safe. So the analogy I like to use here is, if you want to build a box with some stuff in it, don't you build the box first, and then open the lid, and then put stuff in the box and close the lid? Or do you try to build the box with all the stuff in it at the same time? Doesn't make sense to do it that way, but that's what the previous code was doing. So this code builds the box, and then the bottom method opens the lid and puts the data in the box. So now you don't have stuff sticking out of the box and other crazy stuff, right? So that is better, simpler, easier than validation or encoding. It's avoiding the interpreter, just like SQL injection, right? You want to avoid the interpreter, right? So same idea. So now here's another. Let me see. I can't remember what this one is. So here's that selector problem I was telling you about. Now this method takes a selector from somewhere else in the code, and then calls the dollar on it. Now I didn't do any other analysis of this library or this code, but that is fundamentally unsafe. That selector could be coming from user data, could be coming from developer data, I don't know. So that means this method is unsafe, and I have to go find all calls to this spy on method, whatever that is, to see if any user data gets passed in as the selector to this method. So I would recommend they add input validation or encoding or something, right? Now with the new version of jQuery, they can at least go and look at the selector and go, if it doesn't start with less than, then pass it in and you're fine. And if it does start with less than, reject and go away. But in 1.7.2, I have to do some complicated input validation, or I can just encode it. That's probably what I do, is I would encode it, and if it's a normal selector, it's not going to change it. But if it's got weird JavaScript characters in there, it would encode those and make them safe. So that's an example. And then this also talks about, the current defense is validation and encoding, but in 1.8, only dangerous. So that's an improvement since the first time I did this presentation, because that fix wasn't out at the time. So let's talk about how we find XSS flaws real quickly. I'm trying to figure out how much time I got. Not much. So how do you find DOM-based XSS? Well, as a pen tester, it's very similar to the way you do it regular one. You put data in form fields and put it in URLs and whatever, and you can hit go. And whether it goes to the server or not, if you can cause it to pop up, here's your alert. It's very, very similar. So from that perspective, the typical pattern you would use as a pen tester to find DOM-based XSS is the same. Oops. Now, the other model would be to do code analysis, right? So you could load all the JavaScript in and start trying to follow the flows and so on and so forth. But that's really hard, as we talked about before. You've got all this crazy code. It's dynamically being modified. I don't know what methods are safe and not safe. So this is possible, but not super practical right now. Now, the other thing that's weird, though, about client XSS is you can sometimes have what's called unexploitable client XSS. And that occurs where the place you're accepting the input is a place where you can't force a victim to submit that content. So it's like a form field that the user has to type in. Well, it's kind of hard to force a user to type in some content and hit go, because he's not going to type in script, blah, blah, whatever. You're not going to get him to do that, right? Now, you could clickjack him. In other words, you could trick him into not realizing he's there and filling it out. But again, he'd have to type in this big, complicated script. So it's possible, but not likely. Now, in some cases, though, again, if it goes to the server, I can simply skip all the client-side code, force the request to the server, and get there. So sometimes it is not exploitable, and other times it's not. So for example, I found a flaw just a couple weeks ago where you type data into a form, they saved the data in a cookie, and then they got the data back out of the cookie and updated the DOM with it. So you can't really force a new cookie in there. If you could do all kinds of evil already. So I still had them fix it, because it's better safe than sorry, but I couldn't think of a way to force the user to have a cookie without already having a cross-site scripting flaw in the first place to do that. So sometimes you can have unexploitable DOM-based XSS or client XSS, but not always. So don't just say, oh, it's all unexploitable, because you got to think about it, right? So, and of course, it's not just about client XSS in JavaScript. If you can redirect the user to some other website, you can fish them. You can do all kinds of crazy stuff. With HTML5, now we've got client-side SQL and persistent storage and WebSockets and all kinds of crazy stuff. So there's more evil shenanigans going on in JavaScript than just DOM XSS, but we're not even looking at that. Never mind all the crazy new stuff that's going to happen. And the other thing about all this HTML5 stuff is even if your site doesn't use it, the bad guy can. So if he gets a cross-site scripting attack into your site successfully, he can use WebSockets and local storage and all this crazy stuff to build these amazingly ridiculous exploits, even though you're not using any of that stuff. So that doesn't make you more likely to have vulnerabilities. It just makes it easier for the bad guy to be really, really evil to you. So in terms of some technology that's out there that you might be able to get to find client XSS, there's a commercial product that's focused on it called Dominator Pro from Minded. They also have a free version that has less capability. I don't think it's very expensive. It's like $250 or something like that. But it is very, very new and somewhat immature. So probably the rank and file person who's not really an expert in this, probably not going to help you very much. Those of you who are deep into the space, you do a lot of pen testing, code analysis, you can probably get some decent value out of this. I'm hoping over time it'll improve and be easier for everyone to use and less obstacles. It does have a significant performance hit to use this tool, so that is another big drawback of using this tool. There's some free tools out there that I just heard about, so I threw some slides in just to make you aware of them. I have no idea how good they are. I've never used any of them, but I just wanted to give you a list here. So there's the one called DomSnitch from Google. Google does some pretty cool stuff, so it's certainly interesting to look at it. There's another one called Raw2, and then another one called DomX's Scanner. This one's actually interesting. It's not a product, it's actually a service. You go to the website and you type in your URL, and it does some scanning of that website and tries to find vulnerabilities that way. So on the commercial side, beyond Dominator, IBM has done a lot of work in this space. They've built something called the JavaScript Security Analyzer that's built into their dynamic analysis tool, which is interesting. So in their dynamic analysis tool, it scans your website and does what it does, and then also download all your JavaScript. And then they do static analysis on the JavaScript, even though it's a dynamic scanner. So in principle, it sounds really cool, and it's and the nice thing about it is because it's the actual production website, they don't have to figure out like how all this stuff loads. They're doing the actual use of it. I've had the opportunity since I gave this talk originally to actually use that tool on a few, 3 or 4 or 5 customer applications, and it's found nothing. And I know there's flaws on them because I found them by hand. In fact, some of the examples were from the same apps, right? I don't know why. So I'm not saying it's a bad tool. I'm very encouraged by the research. Obviously, they found all these vulnerabilities with it on their sites. But I don't know the differences between how they're using it and how I'm using it. It might be the technology of the apps. But I haven't. So it hasn't been encouraging, unfortunately. Again, not a gigantic slam of their tool, but I haven't seen, ooh, wow, this is amazing. This is really helping me out yet. But it could be the way I'm using it. Another vendor who just claims they can do some stuff is Acumenetics. I've never run it. So I have no opinion there. If you're aware of any other tools, if you're a vendor in the room and you got some cool stuff, I'll be happy to add it to the list. Again, I'm not going to claim you're great or terrible, but at least I'll be complete. And so I'm not aware of any other vendors who specifically said they do it. But I didn't do it in a normal. I didn't really go through every single tool and see if they mention it. So I'm sure there's others. I just don't know about that. So in conclusion, client XSS is definitely becoming a much more serious problem. 25% of our code is, on average, is in the browser now. And we have no clue what methods are safe or unsafe. So we got to figure that out. I'm trying, but I'm only one guy, and I'm doing this on the side. But I'm hoping to get some momentum out there. If I get the jQuery test suite complete, we're going to publish the test harness, the test cases, and the results, so anyone else could pick it up and do it again for another library. They could reuse our tests because they're probably going to be similar. So hopefully that's a big step up to encourage people to step in. And I'm hoping I can get the JavaScript vendors, the library vendors, to go, this is valuable. My customers need this information, and get them to do it. It's their product, right? So get them to do it. And hopefully they'll not only do it, but they'll find flaws and fix them, so those will just go away. And then what's left is, like, here's our safe use. You've got these methods are unsafe. These are safe. And give people a prayer. Right now we have no chance, almost, of doing it correctly because there's just so much we don't know. But if we can get this safe versus unsafe method information out, all the tool vendors could use that. So now they wouldn't have to dig all the way to the bare JavaScript. They could stop at the method calls in jQuery or name your library and go, we know that method's unsafe, bang. So that would make their analysis faster and more accurate, more useful. Because if they tell you this gets called and then the flaw is down here in the bowels of jQuery, you're like, well, how do I fix that? If instead they said, oh, your data went to this method in jQuery and that's the problem, they'd go, oh, well, now I know, because that trace is in my code, I know where to fix it. I'll probably have time for maybe one more question. I'm kind of blinded. None? No more? All right, thanks.